It's connected to a cloud server, and it says it's recording. Okay, so now today our focus is going to be on actually debugging. You know, we've been focusing on PLC software. You learning how to interpret more complex instructions in the logic, which is a very good thing. But I figured now to switch gears so you're not going to get too bogged down with all them ones and zeros in there, all that binary code. Let's just get back to the machine. Let's get back to the machines, and let's just have some real bugs going on, and we're going to try to make it as real as possible. I'm going to get my webcam. I'm going to show you the station. We're at station 6 right now, where it inserts the screws, and I'm going to show you the symptoms of what's going on, and then I want you guys to completely tell me what to do.
Damn.
Now, so do you see that station right there?
Yeah, we see it.
Right. That's station 6 right there. Now I've got the power turned on. I've got the power turned on. And I'm going to bring the webcam. Everything is backwards with this camera. When I move one way, I'm moving the wrong way. So I do have the power on. And if you come down here and look, what do you see wrong there?
No lights on.
There's no lights on, and what are we looking at there? What is that?
But
ELC.
That's the PLC, yeah. Now let's
Yeah.
move on over. What was your question there?
So like for your like, hey Roger, is it whenever like I talk, does the screen go to Connor Faircloth?
No, I set it up where I hit those 3 little dots on Durwood's cam, and I hit the pin video or whatever.
Yeah. How do you
brought
do that?
to full screen.
Okay, I see that now. Okay. Cool. Thanks.
Yeah, Zoom is really nice. I mean, I'm still learning it, but so far I like it actually better than Blue Button.
Yeah, and that's what I saw. A lot of people online were, using Zoom.
Yep, and they say that the Blue Button company tried to stick our college with a huge bill because we're using so much of it that we're using it a whole lot, and so they're dropping the service real soon.
Oh yeah.
So we've got Harry Berto. How you doing, man?
Yes, sir. I'm doing all right.
All right, great. How's your day been?
Been pretty good.
Good. Thank you for joining.
Yes, sir.
Harry Berto, we're at station 6 right now. We're at station 6 where it puts in the screws. I'll back it out. You recognize this right here?
Yeah.
Okay. So I got the power on, but you can maximize my webcam so you can see real close here. But as you see there, we ain't got no lights on the PLC, 0. All right, but if I go over, we got lights on there. So what are those things there?
Those are the relays for it.
Well, they're not relays.
Was it the power source?
Huh?
Power supply?
Power supplies, yes. They're power supplies. So if you take a look, the power supplies are actually on, aren't they?
Mm-hmm.
Yeah.
This is so weird moving this camera around. I go one way and I think I'm going the wrong way. So anyway, the power supplies, but the actual writing is actually backwards, like in a mirror.
Oh, it's right over
I
here.
got that upside down.
No.
No.
Well,
I wonder why that
cameras
is.
flip it around. It
I
says
wonder why
G1,
though.
G2.
Do what now?
It says G1, G2, G3.
It's G1, G2. Yep.
Is it backwards on your screen?
And G3. It's backwards on my computer screen, but is it backwards on yours?
No.
It's not.
No.
Really? I wonder why it is on my monitor, man. That's got me, I don't know. Got me tripping there. I don't know. But anyway, so.
Might be in settings.
Yeah, I have to check into that. But anyway, as you see there, you got 3 power supplies, and the lights are on, aren't they?
Mm-hmm.
Okay, now, so let me get my stand that'll hold the webcam. And I've actually got it upside down. So let me flip it. Y'all still hear me talking?
Yes, sir.
All right.
Yeah, we can still hear you.
When I hear a noise in my headphones, I wonder what is it. So, and this is our first actual full-length session with this. I fiddled around with it yesterday some, and got familiar enough to get started with it. And let's see now. So let me get this here down. I got another camera on the way. It's supposed to come tomorrow, but possibly today from Granger. I got the the wide angle lens, auto focusing.
Oh yeah, sweet.
Oh yeah, yep, all that good stuff. So anyway, so as you can see, you got the power supplies are there, and PLC. So let me actually get it straighter than that. I think I can do better than that. This, yep, I'm a cameraman and teacher. Go down a little bit. Okay, that's pretty good. So we got cameraman and teacher. Go down a little bit.
Yes, sir.
Okay, that's pretty good. And then we have the power supply. So I'd say it's pretty good. That's pretty good view there, isn't it?
Yeah.
Now, so with that being said, let's go. I'm going to show you the schematic for this station. So I'm going to do a screen share. And if I go to there. Now, do you see the screen share?
Yeah.
Yep.
Yeah, we can.
You see that schematic pretty good?
Mm-hmm.
Now, we're at the first page on the schematic, and I want you guys to tell me, where do we go from here? I got a meter. We used a meter. And
We were going from the power supply to the PLC, right?
okay, that sounds good to me. So this is down here. These 3 connections are actually, and let me enlarge that some. Y'all see that pretty good?
Yeah.
Yeah, we can.
So right here, these are the 3 terminals here, to where the power enters the PLC. It says power supply, but this is the power supply connections at the PLC, but the actual power supply is over here. So this machine has that power supply, this one, and this one over here. So it has 3. You know, that what you're seeing in the webcam is you're seeing it actually says G1. You see that G1 over there?
Mm-hmm.
Yeah, I can.
Yeah.
You got G1 and G2 and G3. So this one handles the PLC and the I/O. This one handles the conveyor motor. And this one handles the 5-volt screwdriver, DC screwdriver that actually screws the screws in. So you see where it says 5 volts DC there?
Yeah.
That's a very, very low, very low 5-volt power supply that runs the screwdriver. So here, Roberto, you said checking something between the power supply and the PLC. So where do we go? I mean, what terminals do I go to and all that good stuff? And where do I go?
Freaking X3 8. Is that 18? Hang on, let me go grab my.
Let me go larger here.
I think that's a 15.
I'm gonna grab my paper real quick.
Is it nice and clear now what you're seeing?
Yeah, it
Yeah.
is.
It's better.
Okay.
Yeah, your comment would be X315, it looks like.
X315.
Yeah.
Where are you looking at? X315.
On the 25, leaving
On
the
the power supply is where
supply.
he's looking.
Right. You got an X3 that actually says 14B right there.
I'm talking about
Yeah.
at the
He's
power
looking at
supply
the,
connection.
Look at the power supply, and it says has your 3 lines, your 24 volts, your common, and your FG. I think that's ground.
Right over here.
There at that common,
Okay.
look
Yeah.
up.
Exactly. Yeah. Right here.
Yeah, to your.
Okay.
That's
So you're wanting to
15B.
check it right there at the PLC.
Yeah.
All right. Let's do it. So now I'm going to move over to here.
Hmm.
And let's go down a little bit. And let's go in. Well, actually, I'm going to maximize my screen if it'll let me do that. Well,
I got my paper out, so.
let's see. I got something going on over here. I'm trying to flip around. Let's see, and it did something I didn't want it to do. Thumbnail.
I can still see the.
Right, you can see, but I lost my webcam view. Do y'all still see the webcam?
Yeah. See it.
You do, and I'm not seeing it for some reason. So hold on. Show thumbnail now. There you go. This again, I clicked something. I didn't know what was happening here. Let's see. I go under the 3 dots, and what is it going to let me do? Spotlight the video. If I spotlight, the host has spotlighted your video for everyone. All right. So, do you still see the webcam and the schematic?
Yeah.
I see the schematic.
And then, how about the webcam?
Yeah.
You do?
It's in a little window.
It's in a little window.
Yeah. You can
All right.
switch back and forth between the
Right. That's what I want to do. I want to switch. I want to go back to if I hit stop share. Now did it change it?
yeah.
So now you know what? This is so weird. You see the writing on mine is actually backwards. Where it says Alan Bradley, does that look right to you?
Yeah,
No.
I can see Alan Bradley.
Yeah,
Does.
but ours is the proper way.
Yeah.
It probably
Left to
are.
right.
It probably flips it with the programming or something.
Well, that's going to be a question from Marion Pope. I call her Wonder Woman. She's Wonder Woman. All right, now so.
Or just think of it like the video's being taken on a mirror.
Right. So that's exactly. So the connections that we're looking at from the schematic, and let me get the voltmeter where you can actually see the voltmeter too. Let me move it over. Now on the meter, if you look on the settings right there, you got let's see if I can point. You have a V with a wave on it, and then you have a V with a straight line. Do y'all remember what those two mean?
DC. I mean, AC and
AC and
DC.
DC.
Right. So which one is this?
DC.
Right. And that's what we're looking at now because it's 24 volt DC. So we're going to flip it there. When you're using the meter that has all of these different settings on there, you got to put a lot more thought into it than the basic meter that I had y'all using that only had one setting for voltage. And it would automatically detect between the DC and the AC on that small Fluke T5. On that T5 1000 meter, it would actually detect between the two on one setting. So we're going to go to DC volts there. And it's telling you on the screen also, it should be telling you DC. I don't know if you can see that or not. Volts DC. You see it over there?
Yeah.
Close enough.
Okay. Now, so I'm going to try to position this. Let's see. Let's move. We're going to move this down. And come over. And if I go that way, let's go back. This is a challenge trying to get everything in view here. Now, I think that might work. Let's go up. But if I go up and then tilt the camera down, up again, and then I'm trying to figure out with my camera here what's going to work. Now, I think that'll work. So we're going to check voltage there. And what do we see?
8.3.
0.28.
What's it say?
Point 0.283.
0.283. All right. So is that what do you think about that? Is that good or bad?
That's bad.
Not good.
Not good. Not good. Not good. All right. Now, so if you go back on the schematic, where do we go now? And let me go back to screen share.
Which one was that for?
Go back to screen share.
Okay, so PLC.
Right. So where we just checked it at, we just checked it right here, entering into PLC and those terminals. We didn't go to the X3 terminals on the strip. We actually went right there to the actual PLC to terminals there at 24 and COM. We went right there, and you didn't have anything.
Well, that means you got a problem with your power supply, right?
Okay, that's what it sounds like. Okay, so where do we go now?
You go to your power supply.
Please make sure the power supplies that are putting out now.
Yeah, go to your 24.
Right. Well, we're going to go to the power supply. Okay, so I'm going to stop screen share, and now we're back. And see, I actually like Zoom is actually going to be easier, man. It's definitely going to be easier. It functions way better. I like it. And let's see, I got to get this here. Actually, that there's fine. But boy, this has got blowing my mind here about the writing being a mirror image on my screen. That is so strange. But there's got to be an answer for that. I know there's going to be an answer. So anyway, that's a small problem.
Yeah, at least we can see it, right?
Right, exactly. So let me get a booster box here for my meter.
Could you move the camera back a little bit? Would that help?
I actually could, yeah. All right, so there you go right there. Now, So we're going to check. So what terminals are we going to check on the power supply?
Do you want to go ahead and check G1 first?
Checking what?
Do we
G1
want to go
first.
ahead and G1 first? So that'd be what? Can we check at the terminals, like on it?
Okay. Which terminals are we going to check, or what wire numbers? What wire numbers are we going to check leaving the power?
Would it be 24 and then the common? That'd
Okay.
be 24 and 25, right?
24 and 25. All right. So here we go. 24 and 25.
You got 24 volts.
Yep.
Yep. And I'm looking at Chinese writing on mine. Mine's backwards. That's got me. You know, the blue button didn't do that, but this one here is. But I'll get it figured out.
Well, that's what that extra money was for.
Right. So what do you think now?
Check the other side.
Say it again.
Check the other ones.
Check the other what?
Power supply or the bottom of the power supply.
The bottom. Now, what's
Yeah.
that up here? What we checked right there was the DC that leaves it up here.
Okay.
Now, but the bottom is going to be the AC coming in.
Okay.
Yeah. So check G2 like you did the other one. So that'd be wire
Check.
number. That'd be 26 and 27.
That's right. Okay, you see that?
Yep, and then I reckon check 5 and 29. Yep, there it
There
is.
we go.
Hold on.
That's Durwood's got in the wrong spot. Yeah, that's it.
Well, that's actually for the screwdriver. It's
What?
sitting there at 3.5 volts instead of 5. But you know what? While we're at it, why don't we fix that? Because we're not even dealing with the screwdriver, but I think we can fix that, guys. You see where it says 3.5 volts? It's supposed to say 5. Now, there's a calibration screw at the bottom. This is not to get on another track here, but
Oh, gotcha.
but I didn't know. It's unusual that power supply would be that low. Okay, so there's an adjustment, and let me get it close enough where you can see the adjustment.
Yes, right below the little green light.
And right below the green light, and let's go. If I could get close enough, let's see. Let's go up and down and like that. So right in here, there's a screwdriver adjustment for voltage adjust. It says V adjust. You see that?
Yeah.
Now that you can actually fine tune that and fine tune the output of the power supply. But there's a, let's see. Trying to look at what kind of screw it's going to be.
Looks like a flathead.
Okay. Now let's look.
It's Phillips. Yes, Phillips.
It's actually hard to tell. It looks.
I see 2 lines crossing. So.
Okay, so we're going to see if hold on just a second. No, hold on. Okay, I've got my my little set of screwdrivers out here. And by the way, this set right here, that little set right there, it's Paramount, and it's electronic screwdrivers. You got all of these different ones in there with real tiny little tips in there. This set here was very reasonable. I ordered it through Granger. I don't remember the exact price. It's been a while since I've ordered them, but they're very, very reasonable. And if you don't have a set of real tiny ones like that, you sure need them. So I'm gonna pick a Phillips out of here if that's what you think it is, because it's actually kind of blurry looking to me as to what it is. But it doesn't look like just a plain a flat. So we're gonna try Phillips. Now, so while we're doing that, I'm gonna bring the meter over, and also shoot down and come over. I think I'm going to back out or go up while we calibrate. We're going to do a calibration here. Basically, what we're doing is we're calibrating the power supply. So we're doing the last one, but we got to see up. Now, okay, I think we can manage with that right there. So we got to go back. We're going to put our probes back on the power supply. And you're seeing what, 3.5?
Yep, 3.5.
Now, if there's any room to adjust it, then we're going to find out, is there any room, because I have not tried it myself. So do you see it moving any?
Nope. Oh, yep, there it goes. 4.3, 4.6, 4.7, 4.9, 5.
So but what we just done is we calibrated that power supply. And so what it tells me is the power supply may have been like this for a long time. Now, I remember way back when the machine first came in, I thought I had actually checked that 5 volts there, but and I think I did. But
so it's just got out of calibration.
Something happened there, so it got out of calibration. It did get out of calibration. So
could it have been something with the bug?
Do what now?
Could it have been something caused by the bug?
No. Because look, this power supply here is purely for the screwdriver. Okay, it has nothing to do. It's the G3. It's your G3. It's a G3 power supply. So let me cut off the screen share. Let's go. Hold on. I want to start screen share. Yeah, this software is really working quite a bit better. It's faster on switching. So, do y'all see the screen now?
Yeah.
Schematic.
Yeah, we're good.
So let's go over now to the other power supply. So if you look over here, the G3 power supply is right here. It puts out 5 volts, and it goes. The 5 volts goes out to a relay that's a KA2 relay. And I'll show you where the relay is. If you go, and that relay, when it closes, then it turns on the actual screwdriver motor itself. That's a DC motor. It's just a real small screwdriver motor there. So the KA2 relay turns on that little screwdriver motor, and then your common is right there on 29. So 05 and 29, that's what we just calibrated there. So all the DC power supplies, all of them I've ever seen, they have adjustments on that you can actually fine tune, just in case if you're putting a lot on them and they kind of bog down, you can actually boost them a little bit if you got a lot of things on them, and you can boost them to a certain extent within a certain range. But anyway, and that relay, kind of while we're at it here, the relay, if I go back up, and let's see, I'm going up. So we're going with the machine. I'm going to back up like that and then come up like this and go up. like that, and go straight in. Now, do you see where it says KA2 right there?
Yep.
That right there, that's your relay right there for the screwdriver. And it's a very, very small relay that, hold on. Up under there, under the relay, let me lower this down so you kind of know, because we didn't really go over this stuff, but you sure need it. Go down, and then go up. So right up under here, where my thumb is, it's an ejection. It's an ejector clip that when I pull down, it's actually going to kick the relay out. It's going to kick it right out of there. So it's okay to do it right now because we're actually we got more issues going on. So if you look here, I'm going to pull down with my thumb, and when I do, then it's going to allow me to pull. Then the relay will come out. So y'all see the relay itself?
Yeah.
So
Yeah.
it's a single pole. It's a single pole double throw relay. The two terminals at the bottom here, the two at the bottom, those side ones are actually for the coil. So your coil terminals are right there, those two. And then one of these is going to be common where your DC comes in, and the other one will be normally open and normally closed. So you can actually tell. You can actually tell from the side that that's going to be common right down there. That'll be common going in. And let's see. That's common. Oh. That's common and normally closed and then normally open right there. So right now that normally closed and common are actually together. If you look inside the relay close enough,
Yeah.
it's kind of fuzzy. When I get the other camera, they don't have it in yet. It's supposed to be in tomorrow. This afternoon or tomorrow. Maybe if I flip it around. Oh yeah, yes sir. You can see a whole lot better from there. So
Oh yeah, I can see the contacts in there.
see the contacts now.
Mhm.
So you got you have this terminal, that's going to be common, and the next one up is going to be normally closed, and then the top one's normally open. I think that's right. Let me look at it closer. Hold on. Actually, no.
Hey. Doing good, how are you?
What we can do, I can put a meter on it real quick and tell you. I'm going to put a meter on it and tell you which one's actually normally closed right now, just sitting there as it is. So if I flip the meter over to ohms, and this is weird trying to do this. So I'm going from the bottom one right to there. That's actually ringing. It's actually ringing on the meter right there. When I go there, those two are made right there. So that's your normally closed right there, and then your normally open would be the top and the bottom there.
Gotcha.
Yeah, you can't see the meter at that point right there, but that's actually where it's ringing right there. Well, I can actually show you. Let's see. If I do that, let's go down. Now you can sort of see the relay and the meter too, right?
Yeah.
But when I touch those two, you see it's made now.
Yeah.
I got a connection between those two. And then between the top and the bottom one, I don't. You see where it says OL?
Yeah.
Yeah.
So that's how you can actually identify which one's normally open, normally closed, just with an ohm meter and just pinning out the terminals there. And the coil, if you wanted to actually check resistance on the coil to see if the coil was burned open or not, you just put your ohm meter right on the coil leads like that. And we'll just see what the resistance is.
Mm-hmm.
So the resistance of the coil is 1.34 kilo ohms. You see where it says K ohms?
Yeah.
Mm-hmm.
1.35 K ohms. So the resistance of the coil, the coil is not burned open. And when you have coils, sometimes when a relay don't work, you can actually pull it out and check the coil resistance like I'm doing there. And it's going to tell you whether that blue coil in there is actually burned open or not. It's actually covered in a blue plastic, but in reality, behind that blue plastic in there, there's a whole lot of windings in there, real fine windings like hair-like wire, and those two terminals that are parallel there, up top, those are the ones right there to go to the coil. Okay, so with that being said, let's plug the relay back in, and it's also, if you notice there, it's an Omron. It's an Omron, and it has an LED. So those are like really nice relays. They got a green LED that shows you when the coil is energized. Now that doesn't mean that the contacts are passing properly through. The contacts may be messed up, but the green LED is telling you that there's voltage has been applied to the coil, and so you'll know if it's getting voltage to it. You would know that much. So we'll come back up top. And now if you notice, you see the little swing arm right there?
Yeah.
Yeah.
That swing arm is actually a locking arm. It's a locking lever to where when you put the relay in, that's going to come up and it's going to keep the relay from ever being able to vibrate out. So that's a very good thing for areas that are going to vibrate. And so let's insert it back in very carefully. Now, while I'm pushing the relay, you'll actually see that lever move. I believe it's going to move on its own. It actually did. When I pushed the relay in, the lever actually it actually pivoted up, and it actually locked itself in place. Did y'all notice that?
Yeah.
Snap back.
Yeah, it snapped back on its own. Exactly. It sure did. It sure did. So when you go, and then when you see from a side view, that shows how it's fully engaged now.
Yeah.
So if I hold that like that and I lock that in, and then I eject it out, watch it from the side. It actually kicks it out. So it actually ejects it. The lever actually ejects it. And when you go to push it back in, watch the lever. It actually locked itself. I mean, it pretty much, it did completely. So that's a nice relay base there that's got that on there, that retainer. And it's a really nice relay that has the LED built in. So you got your diagnostics there, and then it can't vibrate out. So Omron did a nice job on those relays there. I worked at a plant, a Japanese plant back in 88 and 89 called Fujicom. And everything they had in there was, most of everything they had in there was Omron because, of course, they were from Japan. The people that run it, they were from Japan. And anyway, so we're back to our original problem. Now we still don't know. We don't know. We got our screwdriver power supply calibrated. You know, we got G3's calibrated now, which was a problem and it needed to be fixed. So we're going to be screwing screws a little bit better now. I'm sure that little motor is going to be running better now because we're at 5 volts, not 3.5. So, but
maybe a little faster.
Do what now?
I said maybe it'll be a little faster now.
Right, exactly. So now we're back to our problem of, you know, that we don't have power there, but we've got it there, you know.
I suppose we need to see if the wires are working properly. If they're making connection.
Okay.
Check out the terminals to make sure all the wires are tight.
Right. Now, so we're going to check now. Let's go down. And let's go in. And down again.
Yeah, we already checked here and we knew it ain't getting all there.
Now, so right there, let me go down and then go up so you can actually see the wire numbers because it's going to take a down view and then looking up to actually see them. Now, so that's actually an ideal spot right there. So at that point, you can see your wire 24 and 25 that came from the power supply, right?
Mm-hmm.
Right now, so let's get our meter. We've got to find a new position for the meter now. Let's go over.
What does the PE represent?
Where's the what?
So what does the PE mean?
Protective earth.
Potential earth.
Okay,
or
gotcha.
protective earth. It could be protective earth or.
So in other words, it's the ground.
It's ground. Yeah, it means ground. Yep. Okay, so I think I'm going to have to hold the meter while we do this because we're so close here. And I'm going to be back out a little bit and then go down some. Just a pinch. And go in like that. And now on the meter, what am I going to set the meter on now? What are we actually checking now?
Volts DC.
Volts DC. All right, so there we go. We were on ohms when we were actually just ohming out the contacts and the coil on the relay. So we're back on volts DC now. So we're going to go to right to there. And what do you see on the meter now?
0.266.
Okay.
0.66.
Right. So what's wrong here now?
Still not outputting enough. Or not getting enough.
Right, it's not getting it there. Okay, so we don't have it there, but we do have it over there.
On out one of the wires.
How about one of the wires?
Make sure the connection's good.
Okay, so where do you want to check that at?
I suppose we need to check the lines that have the power going from them to
To the PLC?
to PLC individually, right?
Okay, so you want to check it out on the power supply end first, or?
Yeah.
Okay. All right. Let's do it. Let's just go over to here.
That'd be 24.
Now, since let's go up. All right, now we know that when we go right here, let's see.
Yeah, we know it's output in there.
We know it's output in there, right? We know that.
Yeah.
So you're getting your voltage. Hold on.
See, the wires all connect somewhere.
Let's get out. Let's get out. Right. Let's get out of here. Go back there one more time. So you know you got your voltage there, right? So it's there.
Mm-hmm.
Now, so you said we're gonna check it right in here, right? So we're gonna have to cut the power off because right now it's actually powered up. So for me to take them out of there, we got to power this station down. So let me kill it one time. If you notice, it took it a minute for the lights to go out. All right, so now let's see, is the DC, is it dead? And
Not quite.
what do you see?
No, it's getting there though.
You're less than a volt, right? You're way down.
Yeah.
Yeah.
So it's okay to check now.
0.1.
Right, it's okay to check it now. It's way down. It's way down.
So we're gonna own it.
Say that again.
So we're gonna check the resistance or whatever. Make sure it's got a good connection.
Well, you actually can. I mean, if you can actually ohm it, you can ohm it from that 24 over to the PLC. Is that what you wanted to do?
Yeah, that's what I was saying.
All right. So let's back it out, and let's see if I can give you a view of both at the same time.
Do the wires all converge somewhere and then go to the PLC?
Now, if you look on the schematic, it does go. Let's see. Let's do us a screen share. If you go back to the schematic and go over. Let's see, I went too far. So that's your PLC connection there. That's the power supply. We got it there. Do y'all see the schematic?
Yeah, we can.
And here you don't have it here, but you do have it there. Now there are some X3 terminals right there. There are some X3 terminals. So you
Check
can
it in there. Make sure it's there.
Yeah.
And make sure that there's a good connection there. And then keep on going down the line.
Okay, now I just powered it off. So it's not going to.
Darwin? Hello?
Power there now. Okay.
Darwin's breaking it.
Mm-hmm. Hello.
Hello.
We can hear you now.
Hello?
Darwood.
Durwood can hear us. Oh, evidently I'm on.
Okay. You hear me now?
Yeah, we can hear
we can
you.
hear you.
Hello?
Hello, can you hear us?
Now? Hello?
Yeah.
Hello, we can hear you.
Now, what happened?
Yeah, what
I'm
happened?
breaking up.
Hold on.
Hey, Connor, are you there?
Yeah, I'm here.
Yeah,
Oh, yeah.
yeah, I'm here. Do y'all hear me?
Yeah, I hear
Yeah, we
Yeah.
can hear you now.
you.
Okay. What it is, it says that the internet connection is unstable right here. Yeah. So anyway, so you're hearing me again?
Yeah.
Yeah, we can hear you again.
Okay, great. What I'm going to have to do is find out from the IT department if we can actually get it boosted up down here. Because right now, you know what? Hey, I know what's wrong. Hold on. Let's see. I'm going through a public Wi-Fi instead of going through the faculty.
Oh, yeah, that could be it.
That's what's wrong. Listen, let me switch. Let me switch real quick. And it automatically joined me to the public Wi-Fi, and that's not as good as faculty. So let me see. Let me see if I can let me back out. Let me see if I can actually see if the faculty Wi-Fi is visible. So do y'all still hear me?
Yeah, we
still
can.
hear you.
Manage wireless networks. So faculty and staff, I'm just going to go to automatically connect. Okay, so let's see now. Is that what I'm connected to? That says public. Can y'all hear me?
Yeah.
Yeah, we can.
Give me a second to disconnect and reconnect, so it's going to quit this
Okay.
mess. Okay, so hold on just a second. That's public Wi-Fi. I'm going to go. Faculty and staff, and hit OK. And let's go back to here. All right, now. So right now, I'm actually on faculty and staff. Do you still hear me?
Yeah.
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 Now, I'm actually going through faculty and staff right now, and it looks like it didn't lose a connection. That's wonderful there.
Mm-hmm.
So I should have a much better connection now. And I've actually made it to where it's not going to connect to the public. I didn't realize I was on public Wi-Fi. I didn't even know that.
Yeah, it was working good right up until it did.
Right, exactly. So anyway, and just for the heck of it, while I'm on there, look, I'm going to show you something here. Do y'all know how to do a speed test?
Speed. Yeah, I remember doing one of those for.
And if you watch, I'm going to do a screen share.
Oh.
I'm going to do a screen share, and I'm going to show you how to check your upload and download speed. Let's see. Let's see if I go here. Do y'all see my Google screen now?
Yeah.
Yeah.
Now you want to go into www.speedtest.net. Speedtest.net. And do you see where it says go?
Yes.
Mm-hmm.
Now you hit go, and it's going to check my upload and download speed to the internet with this connection. And that's a pop-up. I don't want that pop-up in there. I want to get rid of that pop-up. Stop seeing that ad. Not interested. So do you see the gauge down at the bottom?
Mm-hmm.
Yeah.
Yep.
About 7.
About 6.
So it had 6.8 meg on download speed, and now the upload speed's getting ready to check. So it's getting ready to test it.
Looking like 0.
Well, it hasn't tested the upload. It hasn't tested the upload. Let's see. I can wait. It's waiting for a response. Now it's going to check the upload speed now.
Okay.
That's going to be the purple line. And what I found out at home, guys, was I had very, very speed at home. So I had to change internet companies. I went over to StarVision, and I got my upload speed up a whole lot better. And that's what determines the quality of your video. This is fine right here. This is good.
What's good upload speed?
Now, what David Lockwood told me in the IT department is for doing video conferencing, you got to have a minimum of 1 megahertz on upload speed, a minimum. That's bare minimum. It's better to have, say, 3 or more meg on upload speed. Mm-hmm. So this upload speed is fine now, and I don't know what it was a while ago, but it was not good at all. So this is actually very good now. Now at home, I've got something like 30-something meg on download speed, and I've got about 3.7 upload speed. And it's doing fine at night, like when I'm at home doing motor control class live, it's actually doing fine. So you guys should do you a speed test like this with speedtest.net and find out. If you'll let me know what your upload and download speed is, that's an important test to find out before this summer. Because if you're below 1 meg on upload speed, you're probably going to need to look at getting your internet speeded up at home for the summer class. But you may be over that now already. You may be fine. So, but anyway, that's a good tool to use. It's and it's a free tool. You can also do it on your cell phone and check your internet speed on your phone. And that's going to tell you about your connectivity through your data connection or through your Wi-Fi. Okay, so we're back to there now, and let's go back to here.
That's a pretty there.
And let's see. I want to get let's see. Go back.
Got a wall of Lowe's ads and a Nature Valley bar ad.
Let's see. I want to get my full screen back. Hold on. How am I going to do that? Let's see. Meeting controls.
My upload speed's 0.46. Is that good?
No, it's not. No, it's not good for video conferencing. Point 46. That's low. That's low on video. That's low on upload speed.
Yeah. Well, right now I'm doing voice, so it's working for right now. And my mom said she'd look around for better internet, but we live sort of kind of out in the sticks. There ain't too much out here.
I'm trying to get my screens back up larger now. More. Optimize full screen. I don't want to do that. That's not what that caused the problem yesterday. If I hit, let's see, let me go back into new share. No. Where remote control? Why is everything so small now?
What are you talking about?
All of my screens are small now. Instead of everything.
Well, you probably have to. Do you want to see the like your webcam?
What I wanted to be able to see larger, my webcam larger, and plus see y'all. You know, so.
Well, we ain't got our camera showing right now, so.
I go to here. It's showing y'all, and let's see. Hide thumbnail video. Small that. No, I don't want to do that. Here.
Try hitting full screen.
Well, that's what I'm looking for. I'm trying to find full screen here.
Check top right corner.
Top right corner. Go here. I'm losing. What am I? Let's see.
Oh.
Everything. Let's see. I need to get.
Are you in the application?
Let me hit stop share. Now I had to when I hit stop screen share, then it got back normal again. So if I go back now and say gallery view, we're actually okay now. We're fine. We're fine. So you can see. So you see the PLC and you see the power supply. So what do we do now?
Is it still dead?
Do what now?
Is the power still cut off?
The power's still off. Yeah. Yes, off.
Well, I suppose we're going to use the ohm meter to see if there's a good connection on each individual one, right?
Okay, you can do that. That's the thing that you can do.
Cool. Connor, you got any better ideas?
What'd you say?
About how we're going to test this.
Right.
If you were,
I'd test at the points in the line that was on the schematic. I can't remember the number of them.
right.
That'd be, for the first one, it'd be like, what, B1 for, it'd be B1.
I put the meter on ohms there. I did that.
Or the extra one.
Well, if you have it on ohms and there ain't no power on it, you can just check from your PLC to your power supply over there on your
Right.
That's what I was
Just
Okay.
straight.
So that's what we're doing right now. We're checking now. We're going to put the leads together and we see we got a connection with the leads, right? So we have that.
Yep.
So the meter's fine. And so now, and actually anytime you're going to be checking ohms, it's actually good to disconnect one end of what you're checking so it can't backfeed through something else. So let's take this end here loose on the PLC. Let's take it loose, and then we'll use an alligator clip on that wire and check it back over to here. So that's going to be safer to do. Hold on, let me get an alligator clip set. Okay, now, so my recommendation here is that you have a set of test leads that are detachable like this, that you can actually take, that you can pull the probe off of like this and take the probe off and actually go in there and put an alligator clip in there like this and attach that to it. And then you have a way to clip it. And when you have a bare wire in your hands. So now we're going to take the 24 volt loose here. Now we've got our 24 loose there, and we're going to take our alligator clip and clip right onto it like that. So you see that?
Yep.
Now, so we got a good hold on this end, and now we're going to put the meter on the other end where the 24 is, and see what do we have. And so, what do you see?
Looks like 35.
35.
Yeah, like 36. 36. Yep.
So there's something
what,
still.
37.
We're actually backfeeding. We're actually backfeeding. We got a problem in where that this wire where it's hooked. Let's see.
Try testing the alligator clip. See if
What
it's,
we're doing, guys, is when I go right to here to the power supply,
Yeah.
we're getting some internal effects from connecting to it. So we actually need to disconnect this wire here, okay?
All right.
We need to disconnect it on both ends and check it, okay?
Mm-hmm.
So that, because you're really not even supposed to be ohming anything that's actually hooked up to anything. It's supposed to be completely disconnected on both ends when you do an ohm test. So we're going to take the 24 loose here. And let me bring it in closer here.
Could you test it at the X3B1?
You can, but if you're going to do it from one end to another, let's just pull it out right here and look.
Gotcha.
So when you pull it out, what do you see?
The wire's cut off. It ain't.
Wow. Somebody's been monkeying around, fellas.
Is that what you did?
Huh?
Is that what she did?
Ah! So your 24, you didn't have it. I mean, you actually had it on the screw coming out of the power supply, but you didn't have a good connection there, so it couldn't get to the PLC. So we actually we have a clip wire issue here. We have a mischievous instructor.
Yeah.
Mischievous.
See, if we were there, we would have seen that.
Huh?
I said, if we were there, we'd have been able to see that.
Right. Well, so you kind of are. You know, you kind of are anyway. You kind of with me anyway. You're with me in spirit.
Yep.
You ever heard that? So anyway, let's strip that back. You know what? It might work better now. I bet it will. And so let's. Okay, now, so we got that, and now let's find out when we cut the power on what happens, okay? So I'm going to release that.
It still doesn't get it. I'm saying
Well, it's not getting there because, look,
you did it to the
I
other
still
one
have
too,
it
didn't you?
disconnected from the PLC over here. I was jumping the gun here. I was jumping the gun. I don't have the wire hook back up on the bottom of the PLC.
It just
Okay.
has 24 volts just sitting there, you know.
Right, it's just sitting there, and it can't do nothing. So we got to hook it back up on this end. I believe that would help a lot.
Is it dead?
Yeah, you can check. Let's go back to DC. Put our probes here. We'll go back to the power supply. And we'll verify. And so it's dead. You see that?
I don't think you can get any more dead.
Yeah, it's dead. It's dead. It's good. Okay. Now, so we're going to hook the power back up on this end. So it's always good. You want to unhook both ends of whatever you're doing an ohm test on, because you will get, you can, it's very common to get a backfeed condition through the circuit and get a false reading.
Now, it's a good thing you did go all the way to the end, because if you didn't, you wouldn't have known that.
Right. Okay. So, so we're set there now. We got that back in place. And I'm going to cut the power on. And all of a sudden, what do you see going on now?
Right.
Right. Now, it's actually booting up now. And just so you'll see, we're going to check our DC. We know we got it there now, but I'm just going to let you see with a meter. You see it?
Yep.
Got your 24. And the PLC now has fully, it has booted up fully now. And do you see the IO light blinking there?
Yeah.
The only reason that's blinking right there is because we don't have this extra Ethernet connection hooked up. This is the last PLC in the network. Therefore, it has an Ethernet coming into it, but not one leaving going to the next station. So it's kind of looking for link 1, link 2 is the back port. The front port is unhooked right now on this PLC. So link 1's not blinking because there's nothing there. And then IO is blinking because the program in here is actually set up to where I think it's actually looking for, it could potentially go to station 7 and 8, which would be like a warehouse section where it stores the pallets that we didn't have the money to get. So, but anyway, we should be fine there. Everything should be fine. I mean, it normally does that. That's normal for this. So now I'm going to So it said that do y'all still hear me?
Yeah.
Yeah.
It said that Zoom quit unexpectedly. Okay,
Yeah,
but now we're back.
Yeah.
All right. So now let me handle. Let's see. Let's go. So now we've got the station. You got the PLC is booted up fully. You got some inputs on. You know, your power supplies are lit, but we got another issue here. If you look over here, you see the conveyor belt for station 5 is running, but the conveyor belt for 6 is not. You see it?
Yeah.
Mm-hmm.
So the conveyor belt's not working. So this is our next bug here. I had you 2 in here. So we got a conveyor issue now. This is something I've never give y'all. This is a good one here. So conveyor belt's not running, and so we
Make sure there's power going to the motor.
right. So yeah, exactly. So I'm gonna do another screen share. We're gonna go back to our schematic, and let's go to there. So for the actual conveyor itself, this is the first page in the schematic right here. It shows the power supply for the PLC. That power supply is actually for the conveyor, but it shows it continuing for 26 and 27. It goes on to another page. That's for the actual screwdriver. So if you look here where it says, you see 26 and 27 there?
Yep.
Now let's follow that on down. It actually goes to the last page.
Maybe second to the last page.
Okay, now, so 26 and 27, you see that over there on the left?
Yep.
That's where it comes in from that second power supply. And 26 actually goes to a contact. Let me, let's,
KA1 contact.
yeah, KA1 contact. That's a relay. And that contact, when it closes, then the conveyor motor runs. It's a little small DC motor again. So, and the KA1 contact is controlled by a coil that's way over here on the remote I/O. So you see that coil down there?
Mm-hmm.
That rectangular, that's your international symbol for a coil. Where in the US we use a round symbol. Internationally, if you go east or west of the United States, when you cross the Pacific or the Atlantic, they don't draw circles no more for coils. They use rectangles. Okay, so that coil is controlled by the remote I/O. You know, this whole section here, that's your Ethernet module that's behind the machine for remote I/O. That Ethernet module controls this input module and this output. This is the output module. That's the input module, and the Ethernet connection gives you control from the front PLC through this to this output module. And so that coil is what actually turns on, and when it does, it makes that KA1 contact close, and then the motor runs. Okay, so what do we check now? What do we do? We know the motor's not running, so what would you check?
Might want to check that coil.
You're gonna check the coil. Okay, that sounds good. So let me get the webcam set. And so the coil is way over here at KA1. And what's the wire numbers?
It'd be 26 and 27. Or
We're down here at the lower right corner of the schematic.
lower right corner.
Yeah.
Where the coil is, that's the coil itself.
Oh.
So that's the hot wire for the coil, and that's the common. Or actually vice versa. That's the hot over there. 01 is the hot and 25 is the common. So you see the O1, let me go larger with it. Now, is that better?
Yeah.
Now, so that's coil. A1 is hot, A2 is the common for the coil of the relay. And so the wire number is going to be O1 for hot. It comes out of the remote I/O. This is the remote I/O output here. And hold on, let's go over. So it's going to be wire number O1 at the coil at A1 terminal and wire 25 at the A2 terminal on the relay. Okay, so I'm going to leave it right there, and we're going to zoom in to the relay itself.
Parts on 701, parts 701.
And I've got the cut screen share off so I can get a large view of
The webcam.
the webcam. Yep. So there we are there, and let's go down. Down and up. And so what do you see lit up there? You see it's lit, isn't it?
Yeah, see the little green light lit up.
It's lit, and that's good news. That means that the coil is getting power, but let's see how much power. Let's see, is it enough? Might not be enough. So the coil terminals are on the bottom, and let's go down and then go up where you can see. Get my monitor where I can see what's going on. And let's see, we're going to go down and then go up like that. Go in. Go down. Now, so do you see the O1?
Yes.
Yep.
And the 25, okay?
Yeah.
So those are the terminals that we're looking at. So let's go to O1 for hot and 25 for common.
At 25 or 26. No, never mind. Yep,
So what do you see there?
24.
24 volts.
Right, you got your voltage there. The voltage is actually on the coil, and it's actually lit. So it's telling you that the coil's getting the voltage.
Mm-hmm.
All right, so let's go back to the schematic. All right, so do y'all see the schematic again?
Yeah.
Yes.
Now, so you got on 01 and 25, you got 24 volts like it's supposed to be. So that's not an issue there.
Yep.
So let's kind of go over now on the screen. Let's go over. And for every coil, there's going to be a contact, right?
Mm-hmm.
Yep.
For every coil, there's a contact.
Now you can
And
check your
so-
contacts.
Right. So now I'm going to put the meter from where to where?
14 to 11.
From where?
14 and 11.
14 and 11.
Well, okay, now,
Or
you don't want to check across 14 and 11, do you? Not with power on. Don't you want to check the common and then one of
no,
those?
yeah, you check the common. Yeah.
Because we got power on.
Yeah.
So your common is going to be down here on the A2,
Yeah.
which would be,
27.
it would be 27. 27 is going to be common, but that's actually common just for the motor itself. Now, what I found out earlier is when I was planting this bug in here is this, and let me zoom out so you can see kind of an important detail here. So what's that wire number right there?
26.
26.
Right. That is your hot wire going to the relay contact, and then O2 is what leaves it, goes to the motor.
Yeah.
Now the common The common is what?
27.
27. Okay, so 27, we want to put the common on 27, and then we want to put our red probe on
Service on 701, service 701.
26. So we're going to check 26 and 27, right?
Yeah.
Yeah.
So 26 is here, and 27 is actually physically not out here. I've got to go to get to 27. I've got to go back to the power supply.
Yeah.
Because on the relay, there's a 25, there's a 01, and there's a 26. 27 is not even here. The common for the relay is actually 25 for some reason.
What's the X2 then?
For the coil. So if I go from 26 on hot there, and then I go back, and I find 27 on the power supply, like that. So I'm getting 27 over here. Do you see where I'm at over here? Or not? You don't?
Not really the best.
Right there. Now.
Yeah.
I'm getting 27 over there. That's where 27 is.
Yep.
Okay? And then I'm coming back. To 26. I'm going from 26 to 27 there, and hold on. Let's get the meter. I'm checking 26 and 27 right now. And hold on. Let me get out of screen share that I can see what's just remember it's 26 and 27 is what we're looking for right now. Okay. So let's get out of screen share. Now. So 26 is there. Our 27 is way down here at the bottom. And I actually need to put the meter up in view. So let me get the meter in one hand here. All right, now, so what do you see now?
0.
Right. I'm checking 26 and then 27 common. You can't see it because I don't have the wide angle here, but you got nothing there. You have nothing.
Yep.
So there's no voltage going to 26. You see it?
I suppose you,
The contact doesn't have any voltage going. The coil is on, but the contact, what's feeding the contact is actually dead right there.
Uh-huh.
So let's go back to the schematic. So if it's dead right here, if it's dead on that terminal, checking from 26 to 27, then which direction do I go hunting in?
back
You
towards
go back to your power supply.
Back to the power supply, exactly. All right, so let's cut screen share off. And let's go back to the power supply. So if we check 26 and 27 right here, that should tell us something, shouldn't it?
It should.
So see that?
It didn't scan one of them wires out.
You got your power sitting right there leaving that power supply, but it's not making it to the relay contact. See it?
Mm-hmm.
Yeah.
All right, so where do you want to dig into this thing?
On the power wire side, I'd say like right there at the power supply start, and
So right here, you want to actually lift those wires up.
yeah,
Okay, so I'm going to cut it off.
yeah, cut it off. Make sure you ain't doing what you just did earlier.
Right.
They could have done the ground, I suppose. I don't know.
Right, so I've got that off there, and let's go back and check voltage again and see has the DC has it died down yet? And what do you see there?
Nothing.
2.19.
0.19.
Right, so it's less than a volt now. Okay. Okay, so if you look right there, wire looks fine, don't it?
Yep.
That wire looks fine. And then you have actually two commons that are side by side, so we're going to have to loosen both of them at the same time.
Did the commons jumper or something?
They're actually getting common from here and going somewhere else. So both of those look okay, don't they?
Mm-hmm.
Yeah, they look fine. So we'll go back in, tighten them up. So everything is, it looks fine on this end, doesn't it?
Mm-hmm.
Yep. Now you can get to the coil.
So we're back over to the relay now. So let's go back to here.
Did you want to take the coil out and test it?
You can. That's fine. We can do that.
And you probably put a bad one in there.
Okay, so we're talking what, KA1?
Yeah.
Right, so we're going to flip our lever, our ejection lever down at the bottom, and it comes out. So if you're going to just do an ohm check to it, let's bring it down. And we're going to have to go over to ohms. Let's go up. And then down. And over to the horseshoe. The horseshoe and then the annunciator, that means that's a beeper that you get a beeping sound, a really loud beeping sound for continuity. But to actually get the full range of the resistance readings, like up in the megohms, like it says here, you need to be on the horseshoe symbol for ohms, not on the beeper, The beeper, if you go into there, it doesn't go as high in resistance. It doesn't have anywhere near as high a range there. It only goes up to, let's see. Six ohms. The highest it reaches 6 ohms on that setting there. You see that where it says 6?
Mm-hmm.
So if you go on a beeper mode, the only purpose of doing that is when you put the test leads together like this, to hear it ring. Do you hear it ringing?
Yep.
If all you're looking for is a ringer to see do you have continuity on something, then you use that function there where it has the sound, the annunciator, or the alarm, the beeper symbol. It's not gonna get you by for getting a full ohm test, because now if you look, the range goes up into M megohms. Like you see that big M there?
Mm-hmm.
It will read up into the megohms now. To actually check coils, some of these coils read into kilo ohms and thousands of ohms, not, so you have to have you've got to have a range on the meter that can read up into the kilo ohms to actually test some of these relay coils. So here, we're just simply testing right there. We're checking there and then checking the top one. And what are you seeing there now? You're getting
0.1.
Well, it's actually 1.14 something K ohm. See the K?
Yeah. K right there.
Kilo ohm. So
Yeah.
it's like 1,149 ohms. So that coil is actually fine. Small relays, they have a higher resistance because they got real tiny wire. And real tiny wire has got higher ohms than big wire. Big wire has less resistance, so lower ohms. So if you're checking a coil on a big relay or a large motor starter, the ohms are going to be less than 1,000. They're going to be down to probably down around a couple of hundred ohms, you know, or maybe 150 ohms for a large contactor, for instance. I'll give you an example so you'll see it like right now while we're on the subject. So let me grab a contactor. Hold on. So I'm going to go back up here. I'm going to show you something here. You see that starter right there?
Yeah, we do.
Now I'm gonna get that. This is a surge suppressor. I'm gonna get that surge suppressor off of that coil. I'm gonna get it off of there so we can actually do an ohm test on that coil. But you got to get that surge protector out of there because it's going to affect the reading, or it might affect the reading there. So we get that out of the picture there. And we're going to get that out of the way. And I guess I better bring the camera back down so you can see the meter itself. I better do that. Okay. So, I'm simply going into the top where the coil is, and let me just kind of orient it right here. You see where it says A1 and A2 up top? That's the actual coil. That's the coil lead for that big motor starter. That's A1 and A2. So what does the meter say?
59.3 or yeah, 59.3.
59.3 ohms. Now let's get it actually closer so you can see really, really close that we're not in kilo ohms, but we're actually just down in regular ohms. So right now we're in meg ohms. It automatically ranges up into meg ohms, and then when I put the leads back on the coil here, now it's reading what?
59.4 ohms.
Regular ohms, right? It doesn't say K ohms and it doesn't say meg ohms, right? So the important thing here is that you're seeing that you're talking 59 ohms, regular ohms, not kilo ohms and not mega ohms, but regular ohms. Okay? So again, and when I go to read here, you got that reading, and that's where I'm checking it at right there on top of that. Let me back out here, see what's going on. That's the whole starter right there. Okay. You got the starter up top, the contactor up top, and then the overload relay at the bottom there. So on this particular model, your coil is up top on that Allen Bradley. It's up top there, which is A1 and A2. And you see that. So when you're dealing with a bigger coil like this, it takes a really big coil on the inside to bring that thing in and out, you know. Hold on. This is so awkward here. You know, for that, for that starter to pull in and out like that, it takes a big coil in the back of this thing. So there's a really big coil back in here in the back, right back in there. And it has larger wires in there than that little relay. So the bigger the coil, the lower the resistance. And they don't tell you on the side what the resistance is supposed to be of that coil. What you'd have to do is you'd have to go check another starter like this that you know is working okay. If you want to know what should the resistance be, you're gonna have to check another one. Go to another starter and go there and check the resistance on it to get a reference point. Say like on your farm out there, Connor and Cameron, if you were going, do you have a bad coil or not? They don't tell you on the starter what it is, as far as the resistance. You got to physically measure that on a good one. So just pick another one and see what it is, and then you'll have a reference point. Make a mental note of what the resistance is of a good one that's functioning, and then you'll have a reference point to know, do you have a bad coil on another one that's not pulling in. So so that's a very important lesson there about coil. So so with that being said, the coil for that little relay is okay. So let's put it back in.
About that wire that leaves.
Say it again.
It was this. You said the screw was dead, right?
There's no power. There's no power on the screw itself. Yeah. So we're going to put the relay back in. It's back in place and locked in now. So on this particular end of the wire, you didn't have voltage, but you do have it on the power supply end, but not on this end.
So it gets all the way to the coil.
Say that again.
So the power gets all the way to the coil.
Yeah, we checked the coil. Didn't we? We checked coil voltage, I believe. Yeah, we had voltage on the coil, and then the green light came on.
Yeah.
So the coil was fine.
Yeah, the coil was fine. It was just it won't connecting to the.
Right. You don't have voltage on this particular wire right here.
Yeah.
On this end, but you do on the other end.
We'll check that end of the wire to make sure that it's
right. So that's right. So we're going to check here now.
So
we're going to check. We're going to pull. We're going to see what's happening with the wire right there. Yeah. So let's get our.
Hopefully, they installed it properly.
So what do you see there?
Yeah, not stripped.
Installation.
Exactly. So you got a bad connection right there. That gremlin, boy, woo! Somebody's been loose in here, man.
Cutting wires.
I'm telling you. You got a nutty professor, man. You ever heard of a nutty professor?
Mm-hmm.
You got one. You're looking at him.
That's what you do whenever you don't want your job.
Right.
You just go in the plant, cut a few wires, put them back.
Right. Okay, so let's see if we can get this thing back here running again. I got a feeling this is gonna help here. So. And we'll tug on that a little bit. Nice and tight. It is nice and tight. That's very good. Now, what do you think?
Should work.
Work now.
It should work.
I bet it'll work now. I bet it'll work now.
Unless you got a third bug put in there.
No, I don't. No, not on this machine. There's actually a mechanical problem on station 5. And I think what we'll do, we'll probably save it for say Tuesday, because I don't want to hold you guys up a long time. I think these 2 bugs, once we see it running and we cycle it some, will probably be enough for today. We're going to get into some mechanical stuff on 5 that's out of whack. And we haven't been over how to actually do some mechanical adjustments on some actuators, and that's something that's like really important. So okay, so we're going to cut the power on now, and let's see what we got. Actually, when the PLC boots up fully, it causes the relay KA1 to come on instantly. That's something, if y'all remember, the conveyors, they actually come on instantly once the PLC boots up. So as soon as you get all the green lights on there, then the KA1 relay, it goes on ahead and comes on. We'll go ahead and focus on the relay. I think you're getting ready to see it pop on real quick here. It's actually already on. You see it?
Yep. And yep.
So the relay is on. Now let's check voltage up there where we were looking. And so I'm going to go back over to 27. We're going to put the meter back on what? We're checking DC volts now, right?
Yeah, you need to
We got to get it away from ohms, and we got to go back to what?
The straight line with the dash and the V.
We're going from ohms to what?
DC volts.
DC volts, exactly. Okay. So I'm going to go with my common to 27 over on the power supply. And I'm going to hold the meter here, and I'm going to go to 26. And so look at there.
Yep. Oh. What'd you do there, one?
I'm losing connection on my common over there. I'm trying to do a whole lot here with one hand.
Yep. Got it.
Now you see it?
24.
So you've got your 24 volts there going into the relay now, like properly. And so now, let's see what's happening with the conveyor. Let's see if we're going to be able to run this thing, because we're losing a pile of money every hour, guys. This thing ain't running. We're going in the hole bad.
I know we got to put out them blocks.
The plant manager is about to go berserk. Okay, he's getting ready to lose it. He's getting ready to go ballistic over here. So let's see. Let's get this here out of the way. Let's flip this. Let me get the webcam where you can actually see the machine run. I got to flip it. I'll be glad to see that other webcam come in. It's got the wide angle and the autofocus. That's going to be exciting to see it work. Yes, we're getting them from Granger. I've got me one ordered and got Fran Lurky's one ordered. Okay, so if you see, hold on. Let's back up. I'm gonna get a view to where you can see everything. Let's see, the gripper. My hand in here where you can see what's going on now. So that we're back to where the gripper is now. So if you take a look, you see that? You see the back in the background?
Yep.
Now I'm going to push it back. You'll see the conveyor. The conveyor is running now.
Conveyor's on.
Conveyor's on. So now let's see if the rest of the machine is going to work. I'm going to put it in automatic, and let's see what happens. All right, she's running now. So you guys did a great job, man. Great job.
Good.
You've earned your pay today. How does the video look on your end? Does it look pretty sharp?
Pretty cool.
It's a little bit blurry, but it's all right.
Right.
I mean, we can see what's going on.
Right.
If you ask us to
See,
read anything,
I've
I'll tell
actually
you
got the
to go
focus
back.
preset internally inside that camera. Manually, I set it for close up on to be able to read the writing on things like, for instance, like on this. If you can read, I got it set for that. You see how sharp that is?
Yeah.
I've got the focus actually set for that distance, so you can read up close very well. And so it finished up the cycle. Everything's cool. And so I would say you guys done a knockout job, man.
Good.
Knockout job. I'm happy, proud of you. And let's see. Let's get this thing over here. Okay, so here's your nutty professor. And my goal is that you never get bored. How about that?
Oh,
Yeah, right. So I put a lot of thought into what we're going to do before we have a class, so that you're not going to be getting repeat stuff. So nobody wants that. So except when you go to a restaurant, and you get a good fish plate, you do want good repeatability there. You know, I don't want something different every time. You know, I want it a little crispy on the outside when they fry that fish in that peanut oil, and I want it tender on the inside, and I don't want it flip-flop and being something different every time. So that's we do want that the same. So, but anyway, Tuesday, y'all have a good weekend. Tuesday, we got some mechanical stuff going on that we're going to focus on 5. It's actually something slipped on it. And we got to do some mechanical adjustments on the travel on one of the actuators. I'll just show you up front where it is. But we're going to save this for we're going to save it for Tuesday. So this arm right here, that arm right there that brings it, that goes and gets the cap, it gets the cap and goes and puts it on the belt.
Yeah.
yeah.
The position of this is off. It's off in this position. If you look, you can actually tell that it's off.
Yeah.
See how it's off? Yeah, it
Yeah.
ain't right. It's actually slipped. So up here, so hold on. Right here on the arm, you see that screw?
So you have to lease that up and redust it.
That screw right there, hold on. That screw, if I think it actually slipped right in here, where it grabs hold of that shaft.
Yeah.
I think it actually slipped right there because when it's in that position right there, it's off in that position, plus it's off when it goes out to the belt also. It's off in both positions. So it has actually slipped on that shaft right there, right here. It has slipped there. We're going to correct it, but also we're going to look at these adjustments right here.
Mm-hmm.
You see those stud adjustments right there?
Yeah.
With those, we're going to loosen the nut with a box end wrench, and then we put an Allen wrench in the center. There's actually an Allen key in the center, And on that stud there, you put a box end wrench here, an Allen key in the center, and then you break the nut loose and you actually turn that large set screw there. And what that does is it actually sets the positive stops for each end of the stroke. So both of these are actually positive stops internal in the actuator that determines like you see that hard stop right there.
Yep.
That stopping point right there, that stopping point is determined. It's determined by these adjustments right here. So on each end of the stroke of the actuator, when it rotates around, one of these is for this position, and the other one will be for when it swings around toward the conveyor. The stopping points, so they're set there. We're going to get into that stuff Tuesday and fine tune this thing and show you what happens. I'm going to have the webcam like sitting up high over the thing. So let's see. Let's go back. I'll have it sitting up in the air, something like that, and where you can actually see what's going on. And then we'll make the adjustments. Let's see. Let's go back. I'll have it in whatever view that we're doing at the moment, and actually maybe by then, if the other webcam is in, I'll be able to actually have two cameras and switch between cameras because my plan is to be able to have more than one camera going, and I can actually switch from one to another. So again, we'll get into that stuff Tuesday. So we'll get into some mechanical stuff there, and no matter which. If it's a roto linear actuator like this that does the rotary and the up and down, that's the roto part, and the linear part is where it goes up and down here. That's your linear, roto linear. So all of the you have stroke adjustments on the roto part, So anyway, okay, so that's enough there. We'll. You guys have a nice weekend. Thanks for joining.
Oh yeah, you too.
And you guys have done a great job. So hey, I salute you. You did a fine job there. So have a safe weekend. Have a blessed weekend, and hope to see you Tuesday.
All right.
And you guys, if you communicate with anybody else, tell them that we're doing some real stuff. I mean, how do you feel about what we're doing? Do you think it's worth doing?
Yeah, it is. We still need to have class, definitely.
Right. You still need to have class. Y'all paid to learn. And the bad thing, the difference between y'all and Butterball, with Butterball, they're opting not to do this because they know that they can actually pick up from where they left off at a later date, like in August or whenever. Okay. They can actually come back and pick up from that point because they're independent. They don't have to do their class at any particular time.
Yeah.
So for them, they're not opting to do that right now. They may later, but for you guys, once this semester's done, this class is finished. This class is finished. So it's. But when you do come back, whatever physical things that you want to get back in here and do, then I'm willing to use office time and in between times for you to get back in here and get in here in some in between times and do some of the stuff that you didn't get to hands-on do. That if any of you are interested in doing that, you keep it in the back of your mind, and I'm willing to make time to do it. We have to figure out a common time for you and me to get in here and do it, but I'm willing if you're interested. You'd have to initiate that you wanted to do it, and I'm sure we're willing to do it because I feel bad that everything's the way it is. You're not able to be out here and get it, but with the webcam, I'm doing about everything I can think of to make it as real as I can, and so it still prepares you to a large extent to keep learning, So okay, but anyhow, thanks for joining, and y'all have a nice weekend, and God bless you, and hope to see you Tuesday. Yeah, I heard the word, Fred. Okay, y'all have a good one.
All right, Elwood.
You think?
Bye. We'll see you.